When it comes to pesticide applications, backpack sprayers offer a convenient process, whether it's in an agribusiness or a private setting. Being able to use the same piece of equipment for a broadcast application or a pinpoint target, backpack sprayers are a popular, easy-to-use tool. And as with any application equipment, proper calibration is essential to achieving proper coverage and positive results. Without calibration, you increase the risk of over or under spraying chemical products, which could be ineffective, damaging, or even dangerous. With this simple worksheet, you'll be able to see to it that your backpack sprayer is functioning as it should. These are also valuable records that can be used each season to track expenses, as well as the effectiveness of a given sprayer or application program. Though many types of sprayer calibration are completed using a set standard of time or a measured parcel of ground, in this case we're going to calibrate using the actual area being sprayed in order to determine the product output. To start, let's take note of the equipment being calibrated. The first part of the worksheet gathers the basic identification information, along with the date, operator, location, and equipment being used for the calibration. Take note of the sprayer brand, the type and brand of nozzle, the tip size, swath width, and distance to target. A constant flow nozzle tip was used, so that output could only be adjusted by changes in the pump pressure. For this example, a dual compensating constant flow valve CFV regulator was used, set at 21 psi. With a CFV regulator, no matter how heavy or how light the applicator pumps the handle, output will be a steady 21 psi. Mark out the boundaries of the target area. For this exercise, the target bed measures 11 feet by 25.5 feet. While spraying, walk at a comfortable, steady speed and maintain constant pressure. Operate the backpack sprayer with a half tank of clean water at the desired pressure. With a stopwatch, record the time it takes to adequately cover the plot. Perform the time measurement exercise 3 times to create an average spray time for the area. The measured times in this example were 36 seconds, 37 seconds, and 38 seconds. To arrive at an average time, take the total of the 3 figures, which equals 111 seconds. Then divide by 3 for a calculated average of 37 seconds to spray the measured area. Next, take that average time of 37 seconds and at the same application pressure, spray water from the nozzle into a measuring cup, ideally one marked in fluid ounces. Repeat the water collection test 3 times to arrive at an average product discharge for the 37 seconds. In this example, the 3 samples were 25, 25.5, and 25.5 ounces for an average of 25.3 ounces. Convert the ounce total to gallons by dividing the 25.3 by 128 to arrive at an application rate of 0.20 gallons over the measured time. Next, we'll determine the total square footage of the measured or sprayed area. 11 multiplied by 25.5 equals 280.5 square feet. We'll use this figure to convert the application rate to gallons per acre. First, we divide the 0.20 gallons sprayed by the 280.5 of the square footage to determine a 0.000713 gallons per square foot. Then, we multiply that figure by 43,560, the square footage in a full acre, for a total of 31.1 gallons per acre. We can also easily convert that application rate to a coverage area of 1,000 square feet. Take the 0.000713 gallons per square foot and multiply that by 1,000 for a total of 0.713 gallons per 1,000 square feet application rate. Now, let's take that 0.713 gallons per 1,000 square feet and multiply that by 128 to arrive at 91.3 fluid ounces per 1,000 square feet. As you can see, calibrating your backpack sprayer for the variations in each type of sprayed area can be quickly determined accurately by repeating these same formulas. This is important to remember, that calibration isn't simply for the equipment itself, but for the circumstances in which the sprayer will be used. And always read the product label to understand the proper application rate for a given target. Accurately understanding the application rate for a backpack sprayer in the appropriate situation will lead to a better application with more positive results for the targeted crop or area.